Hello, everybody. Welcome to this live webinar being streamed across on different platforms on the subject of cloud computing and GCP certifications. It is my pleasure to welcome you all wherever you are. Good morning to the people in India, but I believe that there are people who've been logged in from outside of India. So good afternoon and good evening, as the case may be. My name is Professor V.M. Swami, and I am the founder director of Infinity EduServe and Consulting, which will now appear on your screen. So could you share the screen, please? Right. So what is Infinity EduServe and Consulting? It's a very broad-based player in the field of education. We have initiatives of a finishing school. We have initiatives of pure play education, online and classroom models. We are associated with academia, but our essence essentially is on 100% placement via skill gap evaluations on every initiative that we launch. One such evaluation program will be done and the information will be given to you as we go along. We have collaborated with NextGen, who are our technical and IT partners. We have a collaboration with 𝐂𝐥𝐻𝐿𝐴 Open University, by which we are accredited UGC partners. So any course that comes under purview will be certified with NextGen or with 𝐂𝐥𝐻𝐿AA and UGC. That is for the future. Right now, we are focusing on disseminating very important information that would help you in constructing your roadmap in the chosen field of cloud computing, and then you can make your assessments accordingly and incorporate it into your roadmaps. Before I hand it over to Mr. Ramakrishna, who is the subject matter expert on cloud computing, and he is going to be the person interacting with you and taking you through this. We are also going to be telling you more information about after the webinar, if you have doubts and difficulties as to where we can culminate and how we can take it forward. Just for beginners, on Wednesday 2nd, a Zoom link will be provided to you. So all the people who have queries and other plans that you would like us to listen to, you would like to bounce off with, we can do that more later. But right now, join me in welcoming Mr. Ramakrishna, who's the subject matter expert on cloud computing, and he's going to be a mentor, guide, as well as the person who's going to take you through this exciting journey of cloud computing. Mr. Ramakrishna, please, all yours.
Hey, thank you, Swami. Thank you very much. Let me share my screen now. Can you see my screen, guys? Can you guys see my screen? Okay, good morning, good evening to some of you. My name is Ramakrishna, and I'm a senior solutions architect. Today, we're going to talk about cloud computing using Google Cloud Platform. A brief about myself. I have been in the software industry for more than 25 years, and I worked for AOL, Verity, Cisco, and HPE previously. And I have been working on cloud technologies since 2013. And I also have a BTech Computer Science and Engineering from JNTU. And I also have an MBA from Santa Clara University. And I'm also a Google certified professional architect. When I'm not doing or working on technologies, I'm also an active hiker. And most recently, I hiked the tallest mountain in the continental United States, Mount Whitney. I'm also a movie lover. I watch a lot of movies, and I also follow tennis and soccer. Okay, so let's get started. So let's take a brief look at our agenda for today. So we're going to start with what is cloud, and we will look at a brief history and evolution, and talk about public cloud and market. And we'll also talk about virtualization, because virtualization is very important when you're talking about cloud. And the cloud cannot exist without virtualization technologies. We'll also talk about containerization and Kubernetes. And then we'll look at a briefly into Google Cloud Services, and followed by the demo of Google Cloud Console. And then we'll also look into Q&A subsequently. So what exactly is cloud? So cloud computing is the use of hardware and software to deliver a service or a network. So typically that is the internet that we're all familiar with. Now, how is that achieved? There are various avenues how you can consume and benefit from the cloud services. That is called SaaS, and that is PaaS, and then IaaS, which is infrastructure service. Now, some of you may be familiar with these abbreviations, and we will get in deep, so you don't have to worry about it. And then before we dig into the cloud, let's briefly look at the history of the cloud. So sometime in the 1960s, if you recall, John McCarthy introduced mainframe time sharing. So what that essentially involved is like there is a resource sitting at one center, and then the same resource is being accessed from far off distances using time sharing. And then back then it was all wired, so it did not really matter so much as to where the resources were located. And then in 1969, we had ARPANET, which is actually the basis for networking. And then in 1970, a premature virtualization software was launched. And then subsequently, we had in 1991 the World Wide Web. For the first time in 1997, a gentleman by name Ramnath Chellappa, he actually defined what cloud computing is. And then in 1999, we had Salesforce coming up. So Salesforce was the first company that popularized software as a service. And then in 2006, Amazon launched Elastic Compute EC2, and also the Simple Storage service. Now, in between these two, and something remarkable happened when VMware came up with the first virtualization software. And early on, most of the virtualization solutions were based on VMware. And then in 2013, by the time we reached 2013, a lot of companies started providing cloud-based services. And then now the market, as we see now, is exploding. So let's briefly look at the cloud market. And there are a bunch of players, with Amazon and Microsoft Azure leading the cloud market. And what's important here is that what we need to realize is that the market is exploding. So essentially, it presents a whole lot of opportunities for cloud providers, and also for companies that want to take advantage of cloud solutions. At the same time, it's also important and pertinent on our part that a lot of the students coming out of colleges, and even those who are employed, would want to embrace these new technologies, and which are not typically taught in colleges these days. So as you see that as the market is exploding, and it presents newer opportunities even for those who want to learn and then use it and monetize the skills set in cloud market. So I think we talked enough about what cloud is. Now, why would somebody want to go to cloud? I think that's a very pertinent question. And what benefits does it accrue? So one of the big thing about cloud is that services are available on demand. What that means is that any service that you want is already available on the public cloud, and In fact, if you look at Amazon provides more than 200 different kinds of services, all cloud based. So whatever you're looking for, it's already probably there. Okay, so that's what means services on demand. Easy access and agility. So okay, so these services are available. How do you access them? Now, these services are easily accessible. All you need is a laptop and a browser and an internet connection, and then you can create and consume those resources in minutes. Now, elasticity and auto scaling. Now, what cloud provides, which is not available or cannot be available on premises or even private cloud, for example, is the ability to scale your resources based on demand. I recall, like 10 years back, during Thanksgiving time, Walmart, there's a surge in demand for shopping, and then Walmart could not meet the demand for the shopping demand, and its Walmart servers began crashing. Now that cannot happen in the cloud. You might ask why? Because cloud is designed to be very elastic. So what that implies is that the resources will scale based on demand. So that can be preset, and so you can say that you can request for 5 resources, and if they're not enough, you can scale them automatically. So that's a very compelling reason why any company would want to go to the cloud. Cheaper and better return on investment. Now, cloud services are cheaper because you know in advance how much your resources would cost. Now, because you can make better estimates, you can also extract better return on your investment. And these cloud resources are highly secure because these resources are located in a data center that are located in remote corners and provide high physical security. I mean, they are protected, secured, and fenced. So it's not like anybody can sneak in. So physically, they're very secure. And I mean, even logically, they're secure too. Global network of resources. Now, if you look at AWS or Google or even Microsoft Azure, they have resources spread all around the world in every continent. So AWS has more than 30 regions spread around. And I mean, what this would benefit is that companies can locally situated in the region can benefit from them. So that would help them in reduce latency, for example. Easy backup and recovery. I mean, since the resources are stored in the cloud, and in fact, for example, storage, if you take, you can take easy backup and recover. High availability. So what does high availability actually mean? So what it means that these resources are available 24/7 without any interruption. I recall like a decade back when there was a patch to be installed on your mail server, and then mail server was down for like a couple of hours so that the transition can happen. But these days you don't need to do that. So that's what high availability means. Sorry. And then the last, obviously, move from capex to opex, and the benefits are that you can upfront what your resources are going to cost based on your demand, and you can plan your investments wisely. Now, all these are good, but then there's some pertinent challenges to cloud adoption. Why would a company not move into cloud? Now, one is security and privacy. I think these concerns are largely overblown, but I think when the cloud technology started off, I mean, there were security and privacy concerns, but they're no longer there as of now, or rather thinning down. On-prem to keep data secure. Sometimes companies don't want to keep their data, for example, on the cloud for whatever reason. So they want to keep it on-prem. Very low latency requirements. Now, sometimes you may want your infrastructure to be hosted where the consumer is, pretty much. Okay. Like for example, your internal engineering resources. So you want it on prem, so that you want very low latency. So that's one challenge to cloud adoption. But then that's kind of thinning down because cloud is now providing very low latency these days. Government regulation. Now, if you look at some countries like China and Europe, they don't want the citizens' data to be stored outside their respective regions. So, for example, I know in Germany, all the data pertaining to their citizens must be in Germany. So, in that case, unless the cloud provider also has a region in that particular country, they cannot win that customer. So, that's the government regulations would prevent companies to adopt cloud technologies. Portability. If your systems are built on proprietary systems, and if those systems are not supported, or maybe you have a unique operating system that you developed, those may not be available on the cloud. So those also can prevent cloud adoption. Now, we briefly talked about service models. The first one is SaaS. When you talk about SaaS, it's a good example would be like a Gmail or Office 365 or your Microsoft Word on the web. So they're all software as a service applications, and then predominantly it has got an end user. You sign up, you pay, and then use it. Okay, so that's pretty much software as a service. We'll take a deep look into SaaS. And then you have PaaS, which is essentially platform as a service. So when you think of a platform, it's like asking, okay, I need a database, or I need a cluster with OpenShift installed, or like Cloud Foundry installed. So that is what we call as a platform. And then typically these are normally used by software developers, and they are the ones who actually deal with it. Now, when you come to infrastructure as a service, so when you think of infrastructure as a service, it primarily means a machine which has, so for us, the things that are of interest are CPU and RAM. So that is pretty much that constitutes infrastructure as a service. Now, normally the network architects and IT admins deal with it. And of course, when you say infrastructure, it also includes networking, storage, and everything, apart from CPU and RAM. Software as a service. Software as a service is a software licensing and delivery model in which software is licensed on a subscription basis and is centrally hosted, mostly dealt by end users and consumers. Now, we talked about this. ServiceNow, Workday, Atlassian, Salesforce, they provide software as a service. So you sign up, you pay for usage per month, like a fixed, normally it's fixed, like it's a $5 per user per month kind of a thing. And remember, when you're talking about the software as a service, we don't deal with either platform or infrastructure because that's all hidden. Platform as a service. So PaaS is a cloud computing model where a third-party provider delivers hardware and software tools to users over the internet. Mostly developers work in PaaS. So Cloud Foundry is one good example. Google App Engine is one. So using Google App Engine, you can actually just take your code, and then a platform is launched for you, and you pay based on the use of the platform. Now, we're not talking about how many resources we are consuming, right? So same thing with the OpenShift Container Platform and VMware Pivotal. Now, the last one is the infrastructure as a service. It's a cloud computing service where enterprises rent or lease servers for compute, network, storage in the cloud. It's mostly the network or IT admins manage these resources. Now, when you say I need infrastructure as a service, what essentially it means is, okay, I need 30 machines, all networked using a single virtual network, and then plus I need some storage. So these are all what we call infrastructure as a service. Now, who is dealing with infrastructure as a service? Pretty much every cloud platform that we know of is dealing with infrastructure service. Rackspace, Alibaba, Google Cloud, AWS. So this is all so good, but before we get deeper into this cloud, and one thing we should remember that what exactly facilitated cloud? What is it different, and what technologies? Because uh, there's something happened that everything is now being seamlessly available on the cloud, right? So the one key thing is what we call as virtualization. Now, if you look at pretty much every hardware device that's out there is getting virtualized. And what that means is rather than being hardware driven, it's mostly being software driven. So one good example in our case would be compute, which and hypervisors facilitate virtualization on compute, like as in virtual machines. Okay. Now, if you look at the picture on the right, you see hardware, and you have the host operating system, and then you have hypervisor. And then on top of that, you have the guest operating systems, which essentially means there are 3 virtual machines. Now, without a hypervisor, it's not possible to achieve that. Okay. Now, and then these hypervisors, and then essentially virtualization facilitates being able to launch multiple virtual machines on a single host. So similar to compute. So what happens is in the compute, if a machine has 6 core CPU, right? And then typically based on configuration, it turns into 12 or 18. I'm just giving an example, 12 or 18 logical CPUs. And then you can distribute this 12 or 18 logical CPUs across multiple machines. Now that's a big achievement where you can now run multiple virtual machines on a single piece of hardware. So similarly, so whatever has happened to compute is also happened to storage, which you call storage virtualization. So when you think of storage virtualization, you have software-defined storage. So you store your data, and it's replicated multiple times. It's nearly highly fault tolerant, because these days, as devices get more sophisticated, now you expect fault tolerant devices, fault tolerant software. So thanks to virtualization and storage, you will be able to get replication, fault tolerance, and very high speed. And then you have software defined networking. So whatever is happening on the compute storage side also happened on the networking side. So when you think of networking, the key pieces like virtual switches and routers, and they're getting virtualized. So what used to happen before, where a switch or router being able to handle 10 customers, now they're able to handle 100, because there's a whole lot of virtualized networking happening underneath. And same thing with network function virtualization. Now, the big thing that differentiates all these technologies, right, from what we had before, is being able to enable multi-tenancy. Like if you have a single piece of hardware, you can actually host multiple virtual machines, and then give each machine to a customer. Now, they wouldn't know that somebody else also using that machine, because that kind of isolation is already being made available, and that's exactly what enables multi-tenancy. So multi-tenancy is what is pushing this cloud forward at a very rapid pace, because without multi-tenancy, nobody would want to go into the cloud, right? So I mean, 2 people, one in Japan and another guy in India, would launch virtual machines, and they could actually be hosted on the same piece of hardware, and they wouldn't know it. And because all these virtualized software provides you the kind of isolation that is actually needed to make it multi-tenant. And then in the last 5 years came containers. Now, whatever has happened, virtual machines being able to maximize the utilization of hardware resources. Now, with containers, you can do even more. Okay, we'll briefly talk about containers in the subsequent slides. And then the other thing you may not have heard is cloud native. And what cloud native essentially talks about is that being able to seamlessly transfer and move your applications from one cloud to another, or maybe from public cloud to private cloud and so on. So it's being able to design your applications so that cloud native compatible, in which case they can move, they can be very highly portable. So defining virtualization is, if you look at the traditional architecture, you had hardware and you had operating system and you have applications hosted on that. And as we move into virtualized architecture, you have a hard piece of hardware, and that could actually be whether it's compute, storage, it doesn't matter. And you have a virtualization layer on top of that. Now, if storage, you have storage virtualization layer or networking virtualization layer or SDN or whatever. And then you have all these your operating systems for various services, and you're able to provide the kind of isolation that is needed for you to host multiple applications, and they're completely multi-tenant and completely isolated. Okay. Now, we briefly talked about containers. Containers are something that's getting very popular these days, and a lot of customers are embracing containerized technologies. Now, why did this even come up? In fact, the way the industry is moving is to be able to maximize resources utilization, and I think containers are the latest. So, containers are lightweight, isolated operating system processes running on a host. Containers run very fast. Okay. Now, remember, if you recall, we already had processes before for a long time, so there's nothing special about it. But then, what's up with containers, right? Containers provide the kind of isolation that virtual machines provide. Okay. So they use the host kernel, and then they have their own bunch of libraries and then applications running on top of that, and they run in a very isolated fashion. Now, in the last 10 years, there's so many technologies came along, which is called C groups, control groups, and namespaces and network namespaces. So these actually provide the kind of isolation and control. So there's no interference between one container or the other. And then the other advantage is that, unlike virtual machines, containers do not need a hypervisor. Now, although this is not entirely true, but what happened was that some of those critical technologies, what hypervisor was using, actually moved into the operating system. So here is where we need to remember, as the technology moves forward, hypervisor and operating system will probably merge at some point. Now, if you think about VMware vSphere, it's pretty much a hypervisor plus an operating system. Okay. Now, what makes them so the lightweight part is one thing, and then they use bare minimum resources. Okay. So all containers on the node share the same operating system. So that's a big leap over virtual machines. Now, because they are lightweight, you can actually launch hundreds of containers on a single machine. So that's a very compelling reason why how containers are able to take advantage of virtualization technologies and being very lightweight. They're essentially processes and achieve strong isolation using kernel features called control groups and namespaces and network namespaces. Now, as you move into the cloud, you'll be dealing a lot and more on containers. Okay, so containers are good, but then when you have a machine and you have like 100 or 200 containers running, how do you manage them? Managing in the sense, managing the life cycle of the container and making sure that the containers don't take more resources than they're needed. So how do you manage all these things? Okay, so here is where Kubernetes comes. Now, Kubernetes is an open source container orchestration engine from Google. Now, Kubernetes came out of Google, and Google has been using this Kubernetes engine within their applications for a long time. And then the technology has kind of gotten very matured, and then it has been open sourced. Now, what Kubernetes does is, when you say orchestration, it doesn't, it's a difficult term to understand, but I'll explain how it works. So it automates computer application deployment, scaling, and management. So it does everything related to containers. Okay, where a container, on which particular node the container should be launched, managing the life cycle, and how many containers should be launched per application, and what if the container fails, what does it do? So it's all managed by Kubernetes. Now it's highly agile and extensible. Okay. Now, when you think about Kubernetes, it's all about giving a specifications like a desired state. Now, the way I would tell is like, I want to run this application with 3 containers, and Kubernetes will figure out and where these 3 containers should be running, and it will figure out where they have to be launched and how many of them to be launched. And then, so it is like a desired state versus current state. Now, what happens if a container runs into an error state? Kubernetes will kill that container and then relaunch on another node or on the same node. So that's what it is. So you define a state and then make sure that the desired state matches the current state. So that's Kubernetes responsibility. Now, horizontal and vertical scalability. So remember, when you talked about cloud, it's all about being able to scale automatically, right? So Kubernetes can launch extra containers when there is a lot more demand, or provide more CPU or RAM to a particular container. Okay, rolling updates with 0 downtime. Now imagine your application before containers. If you want to update, how would you do? So you set a turnaround time and then let your customers know that we are going down and then we are upgrading, and then you upgrade in the middle of the night so that there's minimal impact on your customers. But you don't have to do that with Kubernetes and containers anymore. So the updates happen automatically because like one container is getting updated and the other 2 will work on the old code. Well, the slowly one after the other container gets updated. Again, there are automatic upgrades. Now it's all about reduced operational expenses and the infrastructure expenses. Now, see, although we talked about containers, but I think the actual word that we'll be talking is called the pod. But we don't have to talk more about pods now. We'll talk about pods when we actually get more in depth. Okay, so pod is nothing but a wrapper around container. A pod can host 1 or 2 containers, and it is a minimal compute logical unit in Kubernetes. So Kubernetes deals with pods, not containers, and then pods have containers. So for our discussion today, I think let's stick to containers. So we talked about various cloud platforms. Now there are different types of clouds, and the most prominent you must have heard is the public cloud. A public cloud is a multi-tenant platform that uses the standard cloud computing model to make resources such as virtual machines, applications, or storage available to users remotely. Public cloud services may be free or offered through a variety of subscription or on-demand pricing schemes, including a pay-per-usage model. Now, the good example of public clouds that we know are AWS, Microsoft Azure, and Google, and so on. So the one thing that you need to remember is it's a multi-tenant platform, which means there are so many other tenants sitting on the public cloud, and you don't know who they are, and you don't interfere with them, and they don't interfere with your resources. Private cloud. So typically, private cloud is a computing model that offers a proprietary environment dedicated to a single business entity or a set of dedicated users, and not general public. Let's say you're in your company, you want to set up your own cloud, which you call the private cloud, or sometimes you call on-prem, and you're the only user there. Okay, so it's not multi-tenant; it's for single user. However, it works as the same way, being able to provide services on demand, much like maybe to your employees only. Okay, so as with other types of cloud computing environments, private cloud provides extended virtualized computing resources via physical components stored on-prem or at vendor's data center. Okay. Now, there's something happening between the two now, between private cloud and the public cloud, and there's some kind of a connection between the two, or they're merging. So hybrid cloud is a mix of public and private cloud. So resources located both in public cloud as well as private cloud. So typically the way it happens is you sign up and host your resources or use the resources on a public cloud. However, you decide that I don't want to store the data on public cloud, but instead I want to use it on a private cloud on-prem, or some critical applications that you don't want to be on the public cloud can stay on private cloud. And then you have a standard dedicated internet connection between the two. Okay, so that's pretty much what a hybrid cloud is. Now, a good example of those. So that is fine, but then you may want to have a single platform to manage these, right? You want to see both your private cloud resources as well as the public cloud resources on a single platform, and that's what Google Anthos does, and then also Red Hat Advanced Cluster Management does. And then so these are the two big players, and then Google has its own, and Amazon, AWS, Microsoft also have their own hybrid cloud platforms. So we talked briefly about the top cloud providers. You can see that there is AWS, Microsoft, and Google. Alibaba Cloud is coming up fast. Now, by far, Amazon AWS is by far the biggest. Okay, it's the largest cloud provider, and it's also the pioneer. In fact, Amazon started cloud technologies first, and they have a plethora of services. I mean, anything you want, it's there. There are 200 of those. Okay, it has a high penetration in the market, and AWS makes almost 45 billion annual revenue. And then, of course, we have Microsoft Azure, and then thanks to the captive Windows market, and Microsoft Azure is now the second largest cloud provider, and it capitalized on business with Windows installations, and then all those Windows customers moved to Azure, and it has got very fast growth. And then there is Google, and then the crux of today's discussion revolves about Google. GCP offered by Google is a suite of cloud computing services that runs on the same infrastructure that Google internally uses. For example, for Google Search and YouTube. Now, Google is actually the third largest provider, and it's one of the fastest growing. GCP provides a series of modular cloud services, including computing, data storage, analytics, and machine learning. Now, why GCP? So why are we talking about GCP now? So GCP, though it came very late into the market, made steady, fast progress into the cloud technology space. Okay, it's based on the same technologies Google uses internally, and so so it comes out very solid and tested. Now, Google is in the forefront of innovation in cloud technologies. For example, a lot of technologies that are now using in the cloud, a lot of them came from Google. Okay, for example, Kubernetes came from Google, and container orchestration. And Google also got the earliest implementation of SDN in the cloud. In fact, if you look at the way SDN is defined, you might think that some of the networking companies like Cisco or Juniper would have done this, but then Google is the one that actually revolutionized virtualization in networking. And Google platform services are available across the world, across the continent. Now, one of the things that I personally like about Google Network, I think Google has, between all the cloud providers, Google has got the fastest and the biggest cloud network map. Now, Google also has got its own dedicated undersea cables. So there's a cable owned by Google running in the ocean, as you speak, connecting the continents, and then they have edge networks all around. Now, you might ask why I want to, and we are now pitching to teach Google Cloud, and then why do you want to learn Google Cloud, right? So demand for infrastructure services is exploding. Okay, so every day I get requests for somebody who's a decently well versed with GCP. So a lot of people might want to take advantage of that. A lot of companies wanting to move to cloud. So even though the cloud market is exploding, but still there are 70% of the companies who are dealing with infrastructure have not moved into cloud. So there's huge potential. Again, same thing because of that, a huge employment potential for GCP skills. And because of that, there's also demand for GCP certifications. And one other thing is GCP is expanding, adding more services and expanding into more markets. And GCP certifications are highly valued. So there's a bunch of suite of products that Google offers. We'll not go into detail, but I'm just showing a high-level picture. Now, Google Compute Engine is one of the biggest. This is what you use to build virtual machines. And Google Compute Engine offers scale, performance, and value that allows you to launch large compute clusters. And there are no upfront investments, and you can run thousands of CPUs, virtual CPUs on a system that's designed to be fast. And then again, high performance, scalable virtual machines, industry leading price and performance. And in fact, GCP resources are one of the cheapest. You get low cost automatic discounts, fast and efficient networking, and predefined and custom machine types. You get both Windows and Linux support. Again, Google Compute, there's App Engine, essentially provides platform as a service, which we talked about briefly. And there is Compute Engine, which is essentially infrastructure as a service. Kubernetes, container orchestration. Now, if you look at cloud, container is the fastest growing. So everybody is moving into containers. Cloud functions, microservices, and Cloud Run. So similar to cloud, you have Google also provides storage, highly performant, used to store unstructured data. It's based on Google's proprietary 𝐂𝐤𝐧𝐠 system. And how do you access it? You access through GS util, and it's pretty similar to what Amazon provides. Okay. Now I'm skipping through these slides because we don't want to go into too details about it. Obviously, and then GCP databases. Now, obviously, when you have cloud resources, you must have some database services. So you have Cloud SQL, which is an RDBMS, fully managed by MySQL and PostgreSQL. And then when you talk about Cloud SQL, you get like terabytes of data. And then again, you also have Cloud Spanner, which is also an RDBMS, but now if you want your database to scale to petabytes, that's where you need Cloud Spanner. So it's high on ACID properties, and it's Google proprietary. It's ideal for relational, structured, and semi-structured data. Again, you have Google Cloud Storage. That's a highly scalable NoSQL document database. Again, ACID transactions. It's got SQL queries. And so this is somewhat Google's proprietary. And then you have Google Bigtable. It's a Google's NoSQL wide column database service, similar to Hadoop's HBase. Now, Google Cloud Bigtable is very popular. It's also it is very highly scalable, and we are talking about billions of rows and thousands of columns. GCP's BigQuery. This is a data warehousing service that's really fast. It's cloud-based, serverless, supports auto scaling. It's similar to what Teradata does. And then unlike other services, here you pay by query, like how much data is returned by your query. So that's what you pay by. So we'll talk about how I'll show you briefly how you sign up, what you do. So essentially, when you start on GCP, right, you go to cloud.google.com and sign up using your Google credentials. Uh, what Google does is it gives every new user a $300 credit and valid for 1 year. So which means you can, it's like a buffet. You can consume whatever resources you want as long as you don't exceed 300 credit. Now, when you sign up, a credit card number is required, but they don't use it until the expiry of your credit, and they'll warn you that you're overshooting your limit. So how do you access your GCP services? You can actually go to the console and access. You can also access the Google Cloud Shell, or what you can do is you can install GCP SDK locally on your machine, and then you can configure it to access from your laptop. So this is how you install your GCP Cloud SDK. So one other thing that I want to talk about, GCP certifications. Now, there's the demand for GCP certifications is exploding. Okay, so you can see that the following certifications are being made available. So associate cloud engineer, professional cloud architect, professional cloud developer, and professional data engineer, and professional DevOps. So for the curriculum that we are planning, we are focusing on cloud engineer plus professional cloud architect. I think those two are high in demand, and that course that we are planning starting next week will go in depth into both of these, cloud engineer as well as professional cloud architect. And then the same curriculum will actually meet most of the requirements for cloud developer and data engineer and DevOps too. So what we'll do now is I'll give briefly look at Google Cloud Console, and then show you what is available. So if you go to console, console.google.com. So in my case, I already been using I mean, I already signed up long time back. So this all shows what I have used. Now, once you log in, you actually see what services are available. It shows all services are normal, and if there's any outage or anything, it's kind of reported here. Now, it also actually gives me an estimated bill, like how much you have consumed. Okay, and then the good thing that we need here is to come here. Here you have like plenty of services. Now, I'll touch upon a couple of them that may be of interest to you. And then there's marketplace. So when you think of cloud, right? Okay, it's like you should be able to, whatever resources that you want, whatever you want, should be available through this marketplace, which is like, you want to install Oracle or any database or whatever, it should be available somewhere. So you have Oracle database and Oracle services being made available, or like anything else. So these services are available on the marketplace. And then of course is billing, and then is API and services. But let's talk to something about interesting stuff. So there's Anthos. Remember we talked about Anthos, the Anthos dashboard. Using Anthos, you'll be able to manage your both on-prem resources as well as your Google Cloud resources in one place. I have not enabled in my case, so I'm not going to go there. And then you have this IAM admin. Essentially, this is where you set up permissions to for admin users as well as general users who are part of your organization. Okay. So here is where the compute is. So you have App Engine here, a Compute Engine, Kubernetes, Cloud Functions, Cloud Run, VMware Engine. Okay, and then you have what else? Compute and storage, and you have a plethora of databases you can consume. Networking. So Google has been one of the pioneering cloud provider that provide lot of innovation in networking and then virtualizing the networking. So you have VPC. You can, so when you start working on a project, Google automatically creates a virtual private network for you, and all your resources communicate within that network. Okay. There's operations. You have your resources. You may want to monitor for errors. Okay. Uh, you want to be notified of alert, for example, if any application is failing whatsoever. Okay. So or you want to debug your application. So there are a whole lot of tools that are available. Now, uh, those are the operations tool that we talked about. And then what about the developers? Developers would want to build, deploy, and launch right from a single console. Okay. Or for example, container registry. So what this container registry is like, so a container is built out of an image. Okay. And you need to store these images somewhere. Okay. That's where the container registry comes into. Okay. And then deployment manager. So instead of manually, there are multiple ways, how do you deploy your infrastructure resources. You can access the user interface, or if you want to do it in automated fashion, you can use a deployment manager. So you create resources and then you deploy them using a scripts, for example. Okay. And then you have a big data. Remember, we thought, when you think of a cloud, right, everything that should be there, can be there, should be there. So you have a whole bunch of big data tools targeting towards financial services, healthcare, etc. And the big piece, which is my favorite, is that AI. Now, both Microsoft and AWS provide a lot of AWS AI-based tools, but I think Google's AI tools are the most advanced. Now, uh, pretty soon, a lot of these companies, once their data size grows huge, they want to do something on their with their data, right? Because the data mining can help you pull out consumer behavior. Okay, so you can, if how do you do that? And you need sophisticated AI-based tools, tools that are robust and fairly sophisticated and advanced, and that's what Google Cloud's AI-based tools provide. And by far, if you want to learn AI or if you want to become an expert in AI, I think this is where you should start. And and Microsoft, Azure, and AWS are at least a couple of years behind on this aspect. Okay, and then there are other services that are provided partners who are working with Google. So if you want to pick up any services from the partners, you can do that too. So there's Redis database and Apache Kafka, which is a messaging service, and then Elasticsearch, which is essentially a search cloud-based search technology, MongoDB, and so on. So these are all the technologies that GCP provides, and I think that concludes the presentation as of now. We can actually move into Q&A. So if there are any questions, let me look into the StreamYard. Okay, so do you have any questions? So what I would suggest is that, yeah, I can take questions from now on. Go ahead, please. Yes, can you guys hear me?
Hello. Hello.
Yeah, I can hear you. Go ahead.
Okay. Yeah. Hello, everybody. Am I audible?
I can hear you.
Okay. Hello, everybody. I hope the information disseminated by Mr. Ramakrishna is was adequate. However, we understand that there could be certain gaps in terms of because of internet or audios or whatever reasons. You can post your questions on the chat and your contact details, and we will get back to you.
Okay.
I
So
would urge you to register. Yeah.
go ahead.
Yes,
Sorry.
Ramakrishna, you
No,
say.
no. Sorry.
Yeah.
Go ahead. Sorry. I can.
Yeah. Yeah. So it may not be possible for whatever reasons to answer the queries right now, but if you are able to put them on the chat or in the promotional communication that we had, you have the contact details of the website. You can register there and you can post your queries on the website, or you can send us an email or a WhatsApp. All those details have been provided on the website. Alongside, even in this communication, you will find a chat on your right hand side where there is a series of discussions that is going on right now. So you can put your queries and Mr. Ramakrishna will reply to those queries on the details provided by you.
Okay.
I would request you to, can you share the screen, Ronak, now? Or
Actually, I can see the screen. Questions are being posted. So let me take. So,
okay,
Vishnu
fine.
Mathur, he's asking, do we get certificates after the class? So, what we're going to do is after the class, we're going to conduct an exam, and then based on that exam, we're going to provide a. Well, actually, we're going to provide a course completion certificate, but then you also need to pass an exam, which is
Can I
conducted.
add to that?
Yeah, go ahead, please.
Okay. So I'm just adding to that in terms because it is related. You have the student has two options. One is without the UGC certification that comes at a different structure altogether. So when you're registering for the course, you have two options. One without the UGC certification. Some people require a UGC certification for their career path, etc. Some professional need not have the UGC, so there the Infinity and the next gen certifications would suffice. There are other certifications possible, which I will speak once Mr. Ramakrishna has answered all the queries. Mr. Ramakrishna,
Okay.
yours.
So, okay. So let me continue. We'll take questions. Okay. I don't see any. Okay. Can you explain more on multi-tenant and hybrid cloud? So, Pramod Deshpande. So he's asking about multi-tenant. So essentially, when you request for a service, or let's say you request for a virtual machine, okay, uh, you don't know who else is sitting on the same hardware. Okay, so what that means is that there are like 2 or 3 tenants on the same host. So okay, that is what it means. Now you might think one would interfere with the other. No, in fact, nobody would know who else is on that. Okay, and there would be no interference, and that's what virtualization has actually accomplished. Okay, being able to multi-tenant. And now when you think of hybrid cloud is essentially a mix of private and public cloud. Essentially, you host your resources both on public and host some on public cloud and then some on private cloud, and then provide a network connectivity between the two so that you can seamlessly manage both. So when you think of hybrid cloud, it essentially means a single platform to manage both public and private cloud. I hope that answers your question. But if you have any, you need a further clarification, yeah, you can post it again.
Silent.
Okay, go ahead, please.
Silent.
Any more questions?
Okay. If there are no more questions for this session, of course, you can always post your questions going on the website using the link, and there is a landing page for the cloud computing details, in which you can send your queries via email, WhatsApp, and we will respond to you. However, I would like to share a couple of things with you. Is in the beginning, I spoke to you that Infinity EduServe and Consulting is an educational peer, and all our courses are weaved around 100% placement depending on various factors. Now, this particular course of cloud computing comes with two certifications, like I said. One is with the Next Gen Tech, our partners for IT and technology. Mr. Ramakrishna has been a part of that, and he has rolled out all the benefits to you. In collaboration with Infinity EduServe and Consulting, this is one certification. So it is priced separately, and along with all the three certifications, including Venkateshwara Open University, which is providing the UGC certification, is priced separately. The details of the pricing you will get on the website once you express your interest for either of the courses. Apart from that, once you have registered for the course, you will be complimentary given, as the case may be, in terms of if it is for purely IT purposes and you are an IT professional, then we evaluate skill gaps that may be required, because not everybody brings all the talents to the table at the same time. So we evaluate the skill gaps and we suggest different modules that you can do to fill these gaps. In the case of graduates, you can take an employability test and evaluate as to where you stand and what you need to do. Maybe that on business computing, you need some advanced inputs. Maybe on advanced communication skills, seamlessly interacting and communicating within an organization. These are some of the names that come to the mind, but we have an entire portfolio basket of skilling modules. The other this thing is, there are a lot of people who would not like to be into a career but would like to start their own business, to get into a startup, SME, MSME kind of situation, wherein if you need to test your acumen for entrepreneurial abilities, that also can happen. Now, these would be given to you at the time of you doing the course, and then the results would also be told to you. And then modularly, whenever you can do, when you complete these modules, you would be eligible on different courses for placement assistance or 100% placement, as the case may be. Apart from standalone IT certification courses, we also have converged courses, wherein if you do a standalone cloud computing course, you could also do a converged course of cloud computing with an EMBA or an MBA. For the BBA students, it can be integrated there. So those will be rolled out and it will be put on the website, and we'll reach out to you once you've given your details with all these initiatives coming up. But it is very modular, and therefore, once you start filling the skill gaps, accordingly your placement, your placeability, your employability increases. I want to go to the next slide. Yeah. Now, these skilling courses that we have, apart from Venkateshwara Open University certifications, we are also recognized by the Ministry of Corporate Affairs, Government of India, Ministry of Micro, Small and Medium Enterprises, Ministry of Commerce and Industry, and Department of Labor, Government of India. Now, if you see and explore these parameters of the horizons, if you are going to be working, you would fall under these definitions in one way or the other, and all the courses carry a recognition so that it helps your employability accordingly. I would encourage you to join in for this course and get further details of the courses by getting onto our website, registering on the form over there, and choosing which certification course according to the pricing that has been given over there you can avail of that. I would rest my presentation here and ask Mr. Ramakrishna to please take over. And one more last thing is the recordings of this also would be available on the website, and the links would be provided. Thank you very much for sparing your time. And Mr. Ramakrishna, for your last words, I hand it over to you.
Hey, so if you have any questions, please put. I don't see that there are that many questions coming up, so I'm kind of curious. But again, my intent in giving this presentation is that I want you guys to embrace cloud technologies, and then if you want to start with Google, and then that's very good, because I can help you navigate the path. And some of you might think that I can do all this stuff myself, because there's plenty of information on YouTube, and there's a whole lot of books and literature available. Now, when I started learning cloud technologies, I also felt the same thing, because with so much of information available, right, it can cause confusion, and then you'll actually be spending a lot of time spinning around and not making much of progress. But my intent is that I'm going to guide you guys navigate that treacherous path to Google Cloud Technologies. And I think do a favor to yourself and then embrace this, because these technologies are exploding with opportunities, and then I would want you guys to grab this opportunity, and then Infinity and then Next Gen together with me, we go to collaborate and help you achieve that. And don't waste much time. The course is like 2 to 3 months, and then we would want you to become experts in that, and that's the intent. Well, thanks for attending this session, and then thanks for your time.
Yeah, just one last thing is that the course duration is mentioned on the website. I'm sure Mr. Ramakrishna has also taken it up. This is going to be for 2 hours on Friday, Saturday, Sundays, and it will be run for 2 months. So the total number of hours and everything is put up onto the website, and you will get the course details on that. Right. Thank you once again. Thank you, Mr. Ramakrishna. Thank you to the coordinator and all the participants for having taken out your valuable time and joined us. Best wishes.
Thank you very much.